Hi guys, here's a simple tutorial on how to make a simple Mecanum TeleOp. So what's a TeleOp? The TeleOp period, also known as the driver control period, is the 2 minutes of the robot match where driver commands directly dictates the robot's movements and operations. This tutorial is specifically designed for Mecanum drivetrains. A Mecanum drivetrain is a drivetrain where there is 4 wheels and each wheel is powered by its individual motor. This code does basic functions like move forward, move backward, turn left, turn right, strafe left, and strafe right. So let's get into it. Okay, so the first thing you have to do is create a new file. So you can give it any name. I'm just gonna give it Mecanum test teleop, and then you also have to specify that it is a teleop. So. As you can see at the top, there are these lines. This line says package org.firstinspires.ftc.team code. This basically just states where the file is located. So if you look on this side, you can see that there's one folder. It's called team code, and all of these files are stored in this one folder. So that's just what this package means. This import line basically just says that it's a teleop. Since in Mecanum teleops we do use DC motors and that's a key component, we do have to import that as well. So it's really similar to this line, except instead of teleop, it's DC motor. Basically, it just gives us access to use these DC motors. If we try to use DC motors, if we try to write code using the DC motors over here and we did not import it, then it would give us an error and it wouldn't let us run. And you also have to do this DC motor simple. These two are basically the same. You just need this DC motor simple because it's for changing the direction of the motors. So they're basically the same. They just, yeah. And then one more import you have to do is linear hop mode. What this does is it tells the robot to run each command one after the other. Okay, so once you finish doing your import lines and package lines, we can now actually start writing code. I'm going to add some things and then I'm going to explain it. Okay, so basically this first loop, this first class, this is your public class Mecanum test teleop. So basically, it's where all your drive code is. Pretty much all your code except for these package lines are within this loop. And then inside this class, we have another one, run op mode. This is where all the code that you're going to actually run is in. So when you press play, all the code inside this loop over here will run. Okay, so now what we have to do is declare our motors and then make sure the IDs match our configuration. Okay, so basically, the purpose of this line is it's linking your hardware in your code. So it's grabbing the name you put in your configuration and storing that inside a variable. Basically, this could be anything. This is just the name of the variable you're storing it in. But this name in green and in the quotes, this has to be the name that you put in your configuration, where you configure your motors. If you haven't configured your motors, then this code won't run. It's gonna give you an error that it can't find this. But that's why it's important to check if you have any spelling errors here on your configuration, because this name and the name on your configuration has to match identically. So this could be whatever. This could be just like, you can name it FL to keep it short, or I suggest to keep it as it is because it avoids confusion. But yeah. So this is only for one motor, but we still have to do it for the other three, which is pretty similar. You just have to change the names. Front left motor, and now front right motor. For me, my motors follow the motor names on the configuration follow the same like order or the same pattern, where it's like the first word, for example, F is lowercase, and then the second word, the first letter of the second word is uppercase, and then the first letter of the third word is capital. Some people might have it differently, such as just front left, or left, front. Yeah. It's really up to how your team named it in the configuration. I recommend keeping the name short, but yeah. Now you do the back ones. Also, if you do have other motors, for example, a lot of teams are doing slides. Those are controlled by motors, so it'd be really similar. You just whatever it is, DC motor, left slide, something like that. But it follows the same format. Oh, also over here I forgot to mention that if you're using servos or cameras, you do have to import that too. It's really simple. It's basically what the DC motor thing is, except instead of DC motor, it's servo. For this code, you probably don't have to if you're just doing a simple Mecanum TeleOp. But if you're using TeleOps, if you're using servos, then you do need to import it in your code. Also, as well as for cameras and yeah. So the next thing that you have to do after declaring our motors from our configuration is to reverse the motor direction if needed. This obviously comes with trial and error. So if you're just running this code for the first time, I'd recommend you just run it as is without having the direction reversing code. And if you see that a couple of your wheels are reversed, then you can do this. So say that I run it and I realize that my front left motor is spinning the other way. So I would have to do this. So front left motor dot set. So this basically sets the direction of this to the other way. So if my front left motor was spinning backwards before, and I run this code now, it'd spin forward. If you need to reverse all four, in which case you may, then it follow the same format where, let's say, whatever, back right. Yeah. And then this is where you see DC motor simple come into place, which is why we imported it. As you can see, I added a lot more code. So let's get into it. To be fair, this is the hard part of the code, because there's a lot of like math incorporated, but it's related to setting power to the motors by a joystick controller like commands. So this is the control loop. This loop runs over and over as long as the op mode is active. Inside this loop, we can read input from the gamepad and set power to the motors. Basically, we read 3 values from the controller. Y is the forward and backward from the left stick y-axis. Left stick y-axis is the left Joy-Con moving up and down. We put a minus sign here because pushing forward actually gives us a negative number. And then X, this is the side to side, also from the left stick, and we multiplied this by 1.1 to slightly boost the strafing power, since Mecanum wheels strafe slower than, they strafe slower. And then the last one, RX, is the rotation or turning, which is from the right stick x-axis. So the right stick x-axis is the right Joy-Con moving it left side to side. Basically, when you run this code, pushing the left joystick forward and back should make the robot go forward and then backward. And then pushing the left stick side to side makes it strafe left and right. And then turning is the right stick. Turning is the right stick moving side to side. You can even see it over here. Counter imperfect strafing. Okay, over here is where we do some math to figure out how much to send to each motor. This really isn't necessary because you're not really going to change this. And then this is figuring out how much to send to each motor, and then these lines are actually in the sending power to those motors. And that's pretty much it to a simple TeleOp code. Obviously, if you incorporate servos and slides, the code becomes more complex, but this is just the base for going for a movement. If your robot does not work or doesn't move the way that you expect, then try reversing your motor powers as I explained. Try double checking your configuration names to make sure you got this completely right. And let me know if you have any issues or any questions. Okay, thank you.